Now we'll consider the finding the acceleration and tension of a pulley mass system, where two masses are hanging in two sides of a pulley. Let in this system one mass is m1, another mass is m2, and the radius of pulley is r, mass of the pulley is m, and moment of inertia is I. So from this diagram, let m1 is greater than m2, then this weight of mass m1 will act downward, then it will be m1g will act downward, and the tension of the string T1 will act upward, and for the second mass, the weight of second mass m2g will act downward, and its tension force will act upward. Now as we assumed that m1 mass is greater than m2, so our acceleration for the m1 mass will act downward. This is the direction of our acceleration of the system, and for the mass m2, the acceleration of the system will act upward. This is the direction of our acceleration A. Now we will draw the free body diagram or FBD for mass m1, m2 and the pulley system separately. For the mass m1, if we draw the FBD, then this is our mass m1 and its weight will act downward. Now here is one thing is notable, that as the pulley is not massless, it has certain mass, then tension on both sides of the string will be different, not the same. Now if we draw the FBD of mass m1, that will be equal to in this case for mass m1g will act downward, our tension force will T1 will act upward, and our acceleration of the system will act downward. From this FBD, if we write the equation of motion, then our equation of motion will be m1a, that will be equal to m1g minus T1. This is our equation number 1. Now we'll draw the FBD for second body. So for second body, its weight m2g will act downwards, its tension force will act upward. This is our tension force T2, and as the object m2 is moving upward, so its acceleration will be upward. So this will be the direction for the acceleration for the object 2. Now if we consider, if you write the equation of the motion for this system, then our net force, that is equal to m2a, that will be equal to m2a equal to T2 minus m2g. So this is our equation number 2. Now finding the acceleration of the system, we'll subtract equation number 2 from equation number 1. From this we can write m1a equal to m1g minus T1. This is our equation number 1, and m2a equal to T2 minus m2g. This is our equation number 2. If we subtract these two equations, then after subtracting we'll get m1 plus m2 into a, that will be equal to m1 minus m2 into g minus T1 minus T2. This is our equation number 3. Now we'll consider the equation for the pulley system. If we draw the diagram of the pulley system, later this is our pulley. As we are seeing that the tension in left side, in right side is act in this direction, and this is our direction of the T1, and tension in the left side T2 act in this direction. So if we take this tension T2 in our right side, then direction of our tension T2 will be in this direction. This is the direction of tension T2, and this is the center of mass of the pulley, and this is our radius. Now we write the torque equation of the pulley system. If we write the torque equation, then our torque tau will be net force. What is net force? Our net force is T1 minus T2 into R, because net force into distance equal to torque, and that will be again equal to I alpha, where I is the moment of inertia of the pulley and alpha is the angular acceleration. Again, as we know, R alpha r alpha equal to a. So from this equation we can write alpha equal to a divided by r. So this was our equation number 4, and this is our equation number 5. If we substitute the value of alpha from equation number 5 to equation number 4, then it implies that t1 minus t2 into r, that is equal to I into a divided by r. So from this equation we can write t1 minus t2 is equal to I a divided by r square. This is our equation number 6. Now we'll substitute the value of t1 minus t2 from equation number 6 to our equation number 3. If we substitute that value, then we'll get m1 plus m2 into a, which was equal to m1 minus m2 into g minus t1 minus t2. Now as we will substitute the value of t1 minus t2, then it will become minus ia divided by r square. So this implies if we take all the acceleration term in one side, then it will become m1 plus m2 plus I divided by r square times a. That will be again equal to m1 minus m2 into g. So as a result, we'll get the acceleration of the system a will be m1 minus m2 divided by m1 plus m2 plus I divided by r square multiplied by g. So this is our acceleration of the system. Now we'll find the tension force T1 and T2 separately. For doing that, we'll consider first equation number 1. From our equation number, we'll find T1, that is equal to m1g minus m1a. Now we'll substitute the value of a from our equation number 7. From our equation number 7 into equation number 1. So our value of the tension T1 will be m1g minus m1 into m1 minus m2 divided by m1 plus m2 plus I divided by r square into g. Now we can take this m1g as a common term. After taking common, then our term T1 will become 1 minus m1 minus m2 divided by m1 plus m2 plus I divided by r square into m1g. So if you simplify this, then it will become m1 plus m2 plus I divided by r square minus m1 plus m2 whole divided by m1 plus m2 plus I divided by r square multiplied by m1g. Now we can cancel this m1 and m1. So after cancelling this term, we'll get the value of tension T1, that will be equal to value of tension T1 will be equal to 2m2 plus I divided by r square total divided by m1 plus m2 plus I divided by r square multiplied by m1g. So this is our value of tension T1. Now if we substitute the value of acceleration in our equation number 2, in the similar way we can find the value of tension T2. So that will be T2 will be 2m1 plus I divided by r square whole divided by m1 plus m2 plus I divided by r square times m1g. So this is our value of our tension T2 of the string.